So in this case, we're going from angle A. Now, I always find it useful to actually draw that angle on there because it helps me remember which angle I'm going from. So if I'm going from angle A, I need to figure out the opposite, the adjacent, and the hypotenuse. A big hint when facing these types of questions is I always like to start by figuring out the hypotenuse first. Because after you've done a lot of these, the hypotenuse tends to jump out at you. What would you call the hypotenuse in this case? Yeah, it is C, specifically lowercase c. Now, how do I know that? Two different ways you might be attuned to looking for the hypotenuse. One is, it's the longest side. You know, side C here is the longest side. Or, it is the opposite of the right angle. Either way you remember it is fine. You should get lowercase c for the hypotenuse, though. So I always start with hypotenuse. I then look for what's the opposite. So, the opposite does depend on which angle we're going from. Notice the hypotenuse didn't. In this case, I'm going from angle A, so I'm looking to see what side is on the opposite side of my triangle from that angle. So I'm looking at that side. So you notice then, yes, that is labeled A. Keep it lowercase a, not capital A, because capital A is the angle, lowercase a is the side. So then what's the adjacent? It's got to be B because of process of elimination. We know that it's the other one, but I can also know that because it's the one that's next to the angle, but is not the hypotenuse. If I go from angle B, what will each of those sides be? All right, so again, I'm going to start by figuring out what's the hypotenuse. What is the hypotenuse in this case? It is C, lowercase c. Notice I didn't even need to worry about which angle I was going from because the hypotenuse is always the hypotenuse. It's always opposite the right angle, always the longest side. But for the other two, I do need to use the fact that I'm going from angle B here. So if I'm going from this angle, I go to the opposite next. So to see what side is opposite B, I literally am looking to see what is on the opposite side of the triangle from angle B. You can see there, that's side B, lowercase b. And the adjacent? Well, that's got to be A. So you'll notice that in this problem, I switched which angle I was going from, and the result is that it switched the opposite and the adjacent. Which one was which there? Hypotenuse, though, always stays the same. Now, this is one of the things that we looked at a little bit on our last lesson, that brief one yesterday, or Monday actually it was. Yeah. And then the other thing we looked at was finding angle measures and kind of visualizing where would each of these angles be. And again, this one will be optional to write down as you wish. But I want you to visualize here in your picture, where is 72 degrees? All right, now, first of all, which quadrant is that in? Yep, that is in the first quadrant. How do I know that? Because 0 degrees is right here, and 90 degrees is up here, and you know 72 is between 0 and 90. So it's got to be between 0 and 90 in that first quadrant. Okay, so 72, is that more or less than halfway through that quadrant? Well, let's see. It seems like 72 is closer to 90. So I'm going to say that it's more than halfway through. So I'm going to estimate that it's somewhere up there. I don't want to put it like down here, because that's really close to 0. That's probably more like 15 or 20 degrees, something like that. So I want to show that it's closer to 90 than 0. And so that's the sort of thing you do when you're drawing these angles and what you're looking at. So that's our point for 72 degrees. With that in mind, where would 225 degrees be? Again, visualize that location. So we know 0 and 90 there. It's definitely not between 0 and 90. So if I'm labeling those horizontals and verticals, what's this one? Yep, that's 180 degrees. And what's this one that's straight down?
270.
Yep, that one's 270. By knowing that, I can now know that our 225 here that I'm working with, it's got to be someplace down in this quadrant. What do I call that quadrant?
3.
Yep, that is quadrant number 3. So we know it's in the third quadrant, remember, because it starts as 1 and it goes around that way when we count our quadrants. So then, where is it in that quadrant? Well, is it closer to 180 or 270?
180.
Well, you could actually break out a calculator and calculate it and see, but a surprising fact, at least potentially surprising, would come up here. We'd find that it's actually exactly halfway between them, which is also useful to know here, because that means that if you know that's 225, then you know that if it's less than 225, that it's closer this way, or if it's more than 225, it's closer this way. So those first few problems, these were just bringing back what we talked about in our last lesson, but now we're going into something new for today, or at least new to us this year. It is stuff that you've seen before, though, that we want to make sure these skills are solid. I'm giving you a right triangle. Yes, I do want you to draw this one out on your paper. And we're going to find the unknown side length of this triangle. All right, so you got your drawing, and we want to be looking at what we know and what we need to know. And that's going to tell us what method we're going to be using, because throughout this unit, you're going to be seeing multiple methods to solve this kind of problem. But this one is going to gear us into one of those particularly. So notice we know this side and we know this side. So we know two side lengths here. And what we don't know and what we're being asked to find is the unknown side length. Or in other words, we're being asked to figure out what C is. Every single piece that we're working with here has to do with side lengths then. Now later on in this section, here pretty soon, we're going to be getting into trigonometry with it. Sine, cosine, tangent, stuff like that. You'll need to use that when we have an angle that's involved. But in this case, since we only know side lengths, you don't need anything quite that advanced. What are we going to use to find our missing side length? Yeah, we're going to be using this formula. A squared plus B squared equals C squared. All right. So now we need to start plugging in. The big question, though, is this one that's by itself over here. It's labeled C there. Is that going to be the same as this C? Well, there is one way we can know. When we see C squared written there, it's always the hypotenuse that's being squared. C always represents the hypotenuse. So in this particular drawing, is C the hypotenuse? Yes. We made this one nice and easy, not especially confusing at the start. C is still going to be C. So I can now go ahead and start filling in the rest of it. So between, well actually let's go ahead and fill that in, equals C squared. Now between the A and the B, which one's A and which one's B?
A is B, 6
Does it matter?
No. Wait, it doesn't. 8 is...
If I write 6 squared plus 8 squared, is that going to give us a different number than if I write it as 8 squared plus 6 squared?
No.
No. We're adding them. So the order that we add them in doesn't matter. So between those two side lengths, the A and the B, it doesn't matter which one's which. The only thing that matters is the hypotenuse. All right, now that we have this, we can go ahead and figure out what C is. So first thing we need to do is do the square root. What's 6 squared? 36. What's 8 squared?
64.
The more you know those off the top of your head, the easier these problems get. Okay, now we can do the 36 plus 64.
Equals 100.
That's 100.
Get 10. Whoop. Got it.
All right, and then finally, if I have C squared equals, and we got to get rid of the squared, yes, we're going to square root both sides. So what is the square root of 100?
10.
Yep. And so C equals 10 here. And that's our final answer. That's what we're looking for, is what does C equal, so we're done. If you didn't remember this whole A squared plus B squared equals C squared right off the top of your head, if that was not automatic for you, it should be. This should be a formula that you know and you can use a lot, so write it into your notes if you did not already know that whole problem. Now, one other little detail here that I hope you noticed. Remember, Pythagorean Theorem works only for right triangles. That's because the hypotenuse only is the hypotenuse if it's a right triangle. Otherwise, it's just another side. So we can only use Pythagorean theorem if we have right triangles. So you've seen us do a practice problem. We got the formula down. I'd now like you to go ahead and find the unknown side length in this picture. Go ahead and do it start to finish, and then we'll check our answers after you've had a chance to do it. All right, so check your work and check your answer here. Now you'll notice in this particular one, when we did our original setup, notice here it is equal to b squared. Now remember, whatever this is, it's by itself on the right side. What's playing the role of c is the hypotenuse. In this particular picture, b is the hypotenuse. I know it's not called c, but whatever we call the hypotenuse, that's what has to be by itself over there. And so once you got set up right, then it's just a matter of going ahead and doing the math. Yes, we do get a decimal by doing this square root, so make sure that is correct. I chose to round it to 2 decimal places. That's an arbitrary choice. If you round it to 3 decimals, that would also be fine, for instance. Then one more of this type for you to do, please. So go ahead and please find the missing side length in this setup. All right, so when you do this one, it probably goes a little bit faster because we actually end up with some nice, pretty numbers involved. This final answer just ends up being 25. No decimals, no rounding needed. So I'd now like you to write down this problem. And again, start working it through. But in this case, as you start working it through, you might or might not, depending on how you feel about it, run into a hiccup at a certain point. But at least write down the picture and take it as far as you can. So when doing this one, of course, we are still going to use Pythagorean theorem. I know that because it's all side lengths of a right triangle. But your setup is going to look a little different this time. Because you'll notice that my hypotenuse is actually the 13. So that's my c value. So it's all going to equal 13 squared. So what do I put on the left? Well, that's going to have to be the other 2. So 5 squared plus x squared, or x squared plus 5 squared. The order of those two doesn't matter. It won't change anything. Now, in this case, we can still start by squaring our numbers. So let's go ahead and do that. So 5 squared, that's going to be 25. X squared is still just x squared. And 13 squared, that's 169. Now that I have the equation looking like this, I still want to know what x equals. Well, if I want to know that, I'm going to start by getting the x squared equals. In order to get there, subtract the 25 from both sides. And so in this kind of a problem, the difference is that we're actually going to be subtracting our 2 squares instead of adding them. Now when I subtract them, that gives me 144. Now I'm going to go ahead and take the square root of both sides. So I'm going to do the square root of 144, which is a nice, pretty number. What is the square root of 144?
12.
It is 12. And so that then is our final answer. X equals 12. To practice that idea, here is another one, a slight variation on the theme. Please find the missing side length in this one. Now in this case, I didn't have that unknown side labeled, so I went ahead and gave it a name. I called it X. And then I start setting it up. And again, whenever I set it up, I'm always just making sure the hypotenuse is whichever one is by itself. And so when all said and done here, we should get an answer of about 17.86. You can see the work involved there. So that if you didn't get that, you can go ahead and check and see what happened along the way. Now, one thing that does happen at a certain point is I know a few of you are probably tempted to change your original setup. I think some of you probably tried writing something like this instead. You probably did like x squared equals 20 squared minus 9 squared. Because you're looking ahead and you're thinking, oh, well, I know I'm going to have to subtract. And while that technically is correct, if you set it up that way, then you're all of a sudden expecting yourself to memorize 2 different forms of the Pythagorean theorem. I don't really like memorizing things. Why memorize 2 when 1 will do? Because you know how to do the algebra. So I'd always recommend setting it up this way and not trying to cut that corner. Otherwise, you'll forget something at some point and it will cause some problems. So then, now we're going to take a look at this kind of a setup. Now notice in this problem, there's no picture, and yet we still can use the same kind of tools that we've just been using. So we're told in words here, a right triangle has legs that are 3 centimeters and 4 centimeters long. And how long is the hypotenuse? Now you'll notice here I'm using the vocabulary of legs. Legs are basically those other two side lengths in the right triangle. So we know the hypotenuse is the special name in the right triangle. The other two are just generically called legs. Now, for some of you, you're just going to look at this description and you're going to know how to set it up. That's fine. But if you don't, like if you're doing this problem on a wall map or assignment or something like that, and you don't instantly know what the setup should be, draw it. Because when we see the drawing, it resonates. It looks familiar. This is like what we've been saying before, and then we can go ahead and figure out how to do it. And so I'd go ahead and label my hypotenuse. I'm going to go ahead and call it X this time because I'm not very creative like that. And we'd use Pythagorean Theorem again. I know to use Pythagorean Theorem because it is a right triangle, and I'm just dealing with side lengths. So we do 3 squared plus 4 squared equals x squared. And this one actually ends up being really easy. In fact, this one's so easy, a few of you might even have known the answer before you even did the calculations. Now, how could that be? There's something called Pythagorean triples. They're just combinations of numbers that always work in the Pythagorean theorem. One of them is the 3, 4, 5 triangle. Anytime you plug in the combination of 3, 4, and 5 into the Pythagorean theorem, it works. So I actually knew what the answer was just because I knew that fact, and I said, oh, it's 3 and 4. The other one must be 5. So there's a couple little tricks like that you might get to know with enough experience where you start seeing certain combinations come up a lot. Now, when you notice things that fit in the Pythagorean theorem, it also lets us figure out other things. Like, here's a whole nother type of question, but closely related. We have a triangle. I'm not telling you what type of triangle it is. It has side lengths that are 5, 10, and 12 feet long. Is this triangle a right triangle? Well, in order to know that, we actually can still use Pythagorean theorem, and it might be worth noting as an addition to your Pythagorean theorem notes. So this is optional notes. You can add this in right now if you want to. Basically, if I can take those 3 numbers, and if they work in the Pythagorean theorem, that is a squared plus b squared does equal c squared, then it tells us that it's a right triangle. If it doesn't work in the Pythagorean theorem, then it is not a right triangle. And when you go to plug it all into the Pythagorean theorem to check it, notice the hypotenuse is always the longest side of a right triangle. So whichever of your 3 sides is longest, put that in to play the role of the hypotenuse while you check it. So let's go back to our example here. We want to know if this triangle is a right triangle. Now, first of all, notice 12 is my biggest side length. So that's going to be the one that I'm going to be putting in for C. So when I write this out, I'm going to go 5 squared plus 10 squared. And I want to know if that equals 12 squared. So it's kind of like I'm trying to figure out, does it actually equal that? And so we're going to go ahead and just do that math on each side. So 5 squared, I know that off the top of my head. 10 squared, I also know that off the top of my head. I like these when they're easy like that. 12 squared, yes, you should know that one too. These squares come up so much, yeah, the better you know them, easier life gets to be. So I can do the 25 plus 100. Okay, that's 125. Does 125 equal 144? Nope. Therefore, is it a right triangle?
Nope.
Nope. And so the final answer here is no. It is not a right triangle because it did not satisfy the Pythagorean theorem. And so having seen how this one works, I want you to practice the same routine with this problem. Here's another potential triangle. We want to know if it's a right triangle. Check it and see. All right, so when you go and set this up, the longest side, remember, is the one that's by itself, so it's going to be equal to 17 squared. And then we go ahead and we just do those calculations. When I do the 8 squared plus 15 squared and do all that work, it ends up giving me 289. 17 squared, also 289. So they're equal to each other. Therefore, yes, this is a right triangle. All right, having gone through all those, we're just going to do one last problem here together. This is the last one. Yes, it's going to be a story problem. So please, take a moment and start working through this problem. So like write down the problem, or at least the essentials of it, and start working it through to see how you would approach it. So the first thing I do like to do with a problem like this is I do like to turn it into a picture. We know he's starting from his house here, so I got the house there. And he drives 240 miles west. Yes, you should know your compass directions. So that then is west. So he goes 240 miles to the west, which if we're looking at a map means to the left. He then is going to travel 70 miles north. So from that same location, he then goes north. So that's going to then be 70 miles. Now the question we're asked is, how far is the gas station, which is where we ended up here, from his house? Now when we're asked that, basically, if we look at two distances, it has to be a straight line distance. So we're trying to figure out that distance there. Or if I made it a very basic drawing like a geometric, all we're doing is looking at this triangle.
Wait, why is the triangle not full?
And so once we have our picture, then we can go ahead and apply it to Pythagorean Theorem. So I'm going to go ahead and call that length x. Yes, you could call it other things too. You could call it c, just because it fits nicely with Pythagorean Theorem. You could call it d for distance. You could call it Fred for all I care, but give it a name. And then we can go ahead and plug in Pythagorean Theorem. And so as we go through and do all of that work, you can see it adds to 62,500. And then I'm going to take the square root of that. And thankfully that does give me something that's pretty clean. It gives us an answer of 250. Now in this case we were actually given units, so I want to remember to include those. So I'm going to go ahead and give my answer then as 250 miles.